Hi guys, good evening everyone. Yes, good evening guys. How are you all? I hope everyone is doing well. So, what we have to do today is we'll be continuing the topic that we did in the last class. We discussed about solubility, Henry's law, and we completed that topic. Now, today we'll be starting with the Raoult's law and how you can define a solution into ideal solution or non-ideal solution on the basis of Raoult's law. That's what we are going to learn. So, yes, today's session is going to be really interesting because for sure you can expect one question from Raoult's law, and this is really important, guys. So make sure everyone is attending this talk, this session, as well as yes, everyone is going through this video. Those who are not in the session right now, but those who are seeing it later also, you should see it because we'll be learning many of the things related to a Raoult's law, which is going to make it very easier for you to understand as well as do the questions. Yes, very good. So let's just start with it, guys. Yes, but before that, obviously, those who are new on the platform, they are curious to know about me. They want to know about the educator. So, yes, I am Manisha Rani, your chemistry educator at Unacademy, and I have experience of online and offline teaching at reputed institutes for more than 5 years. I have done my master's from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR NET, and GATE, and I have given a really good ranks through my students in the industry for the NEET and JEE Mains. Yes, and I have given around 500 plus selections in NEET and AIMS and 800 plus selections in JEE Mains and Advanced. And I am a plus verified tutor, guys. So let's just talk about little bit regarding the classes. So first thing, if you want to know about the classes schedule, the notes regarding related to the classes, as well as few of the books, their hard soft copy, even the handwritten material, so everything, yes, you can get how by joining this Telegram channel. Yeah, so this Telegram channel, how you can join it, either you can scan the code which is showing on the screen, or you can use the link which is given here, and you can join the Telegram channel where you'll be getting all the information. Now, talking about the special classes which are there on our Unacademy platform, Unacademy app. So what are the special things about the special classes? So the special things about the special classes are you can learn from your favorite educator. Yes, you can engage with the educators via polls, so there will be a good communication and interactions. You can clear your doubts in the live special classes. You can inform that okay, these are the topics which I'm facing difficulty, and what you can do, yes, you can inform the tutor, you inform the educator, and that topic can be covered in the special classes, so that is a good thing. Other than that, let me tell you about what are the special class timetables, so which is going to be there on your Unacademy app. So it's very simple, you just have to download the app. Yeah, you have to choose your goal, and then after that, yes, you can check the special classes which are absolutely free. The 28th June, we have done a session discussion on name reactions from alcohols and phenol. So this video also you can check, which will be already there, a recorded session. You can check it. And 5th July, there will be a session. So from 5th July, guys, we are starting a series of organic chemistry basics, because this is a very important thing. Many of the students, they are facing difficulty in 12th standard organic chemistry because of the lack of basics from class 11. Okay, so what you have to know is very simple. You can brush up all your 11th standard organic topics. So all the topics where you felt difficulty in 11th standard, and now they are not going to affect you anyway, because before starting with your 12th standard organic, will be brushing up all these topics. And when we'll brush up all these topics, yes, it will be really easy for you to, yes, you to even understand the 12th standard organic chemistry. Very good. So we'll be doing all the basics. So first we are starting with the Iupac Nomenclature, which will be there from 6:30 to, like, which will be there from 5th July. 5th July, it will be there Iupac Nomenclature part 1. So in first class we'll be learning about some basic rules, and second we'll be learning about all the examples we'll be doing, like both will be doing. So yes, make sure you're joining these special classes on Unacademy app. Now talking about or you can join through the website as well, guys. Now Unacademy subscription features, let me just tell you about it. Yeah, what are the best features that you can see? Yes, that you can learn live from the comfort of your home. You have the unlimited access to all courses. Just a second, guys, what is this? Yeah, so what you can relate is very simple. You have many of the things, many of the good things about the session. Yes, the Unacademy subscription features, what are those? Like, you have a top educators of India, they are all together in one platform. You have unlimited access to all the courses. There are regular doubt resolving sessions. There is an exhaustive coverage of syllabus, guys. We follow the complete syllabus which is given by your IC board, and will be covering each and every topic. Then there is a complete mentorship and guidance. You will be provided with the study material in the PDF format, which is easy to access, and you'll be having the practice test as well as live test series. So this is a very important thing, guys, because in this live test series, what you can relate, it's going to help us to understand, it's going to help us and you to understand that what level you are in right now, and how many topics you have understood well, and how many topics you are lagging somewhere, and where we have to work hard for you so that we can help you to improve better. So this is what we see in the live test series, like, because obviously you'll be writing the test, and the score that you're going to get will be able to understand that which in all topics you are not able to solve the questions. Yes. Then talking about the batch courses, we have all the batch courses, guys, so which you can see. Okay, very good. Now talking about the Unacademy Plus subscription, so it is the price is here, right, which is shown to you. But let me tell you, guys, the 20% discount is going on. Yes, 20% discount is going on, and today is the last day to avail it. Yes, today is the last day to avail it. Few hours left, guys. You can get instant 20% discount on your, yes, you can get 20% instant discount if you'll be using my code, which is MRIS10. What is the code, guys? MRIS10. So if you will use this code, you will get instant 20% discount on the subscription. Already the Unacademy prices are very nominal and affordable, but yes, the offer is going on, and which is going to make even the quality education more, yes, affordable. So yes, all of you guys can enroll for the course, and you can use my code, which is MRIS10. Now let's just start with the topic, guys. So last class we discussed about Henry's law, and what is Henry's law? Let me just quickly revise it up, what we got for the Henry's law. So Henry's law, we understood, is nothing but it is P is equal to KHX. Correct? P is equal to KHX is your Henry's law. Now what you can relate, what is the P over here? Tell me, guys. Yes, what is the P over here? P is the partial pressure of the gas. KH is the Henry's constant. Yeah, partial pressure of the gas. KH is the Henry's constant. And what is X? X is the mole fraction. So this is what we understood. We also discussed some of the characteristics of KH, that how you can get to know about the KH and what and all things you can understand about the KH value. So this we have understood. Now let's just talk about some of the applications of Henry's law. Yes. So this topic will be continuing, and then we'll start directly with the vapor pressure and Raoult's law of vapor pressure. So what are the applications of Henry's law, guys? So tell me a very simple thing. You guys must have seen, no, that when we open the cold drink bottle, yes, if you little bit shake it and just open the cold drink bottle, what happens? How many of you, I can bet that out of, say, how many students we have, right? So 99% of you, yes, you must have made the cold drink fallen from the bottle whenever you are opening it. Yes, tell me, everyone, this happened with you, that whenever you open the cold drink bottle, some of it falls down. Yes, happens? Tell me. Or when you are putting in the glass, it falls down. Seen it, guys? So one of the application of Henry's law is there in the carbonated drinks. So in carbonated drinks, you add the carbon dioxide with the high pressure, right, to the bottle. So carbonated drinks, what you can relate, guys, yes, in that how you add the carbon dioxide in the cold drinks or in the liquid, whatever you have, yes, how you add it under high pressure. So the solubility increases. Other than that, what you can relate the application is in scuba divers. Yes, scuba divers also carry the cylinders. Even in that also we can relate the Henry's law is applicable. And last but not the least, mountaineers, right? Mountaineers carries oxygen cylinder. So how that oxygen is there present over there. So that is also one of the application of Henry's law. Tell me, guys, why mountaineers carry oxygen cylinder? How many of you have seen it and you found it like really fascinating, that people who are doing scuba diving and the people who are going on the mountains for climbing? Yes, how many of you like it? Yes, how many of you find it fascinating? Tell me, guys. Yes. No, you found it fascinating, right? So what you have to know is very simple, guys. What you have to know is very simple, that even the oxygen cylinder doesn't contain oxygen. It contains even some inert gases which is going to help to maintain the level, because if I talk about in air also, you don't have 100% oxygen, right? So you require some dilute amount which is going to be helpful, and it's not going to cause any problem. Okay, so this is like, if you want, you can just go through a little bit, you can do a research about it. You will find it very interesting. And if you get any doubt regarding these, you just let me know. I'll be telling you in the next class. Okay, very good. So applications of Henry's law we have understood. Okay, now let's just talk about for the liquid solutions some of the terms that we can relate. So what is vapor pressure, guys? Yes, so let's just start understanding about vapor pressure first. Tell me, everyone, what is vapor pressure? Yes, everyone should answer what is vapor pressure. Yeah, and how you can define it. Tell me, guys, it's very simple. No, pressure exerted by the vapors of liquid is called as, yes, vapor pressure. Very simple, right? So vapor pressure is the pressure exerted by the vapors of the liquid, right? Pressure exerted by the vapors of the liquid is called vapor pressure. Correct. Very good. Now what do you think vapor pressure depends upon which and all factors? Yes, what do you think vapor pressure depends upon which and all factors? Tell me, guys. So it depends upon, yes, it depends upon few of the factors. What are those? First is nature of liquid. Yes, it depends upon one, nature of liquid. Two, it depends upon, yeah, the boiling point and temperature. Boiling point and temperature. Now talking about the nature of liquid, the first thing which you can relate nature of liquid. So what do you have to know? What do you mean by nature of liquid? So you know that if I talk about the different liquids, like if I talk about alcohol, HCl or anything, what you can relate is that very simple. They all are not going to have the same force of attraction between the molecules, right? So that's what you can relate. So what you have to know, if you will be having a strong force of interaction, right? So force of interaction is inversely proportional to vapor pressure. Force of attraction is inversely. So the nature of liquid means what is the force of attraction between the particles. So force of attraction is inversely proportional to vapor pressure. So the force of attraction increases, vapor pressure decreases, because obviously it is going to take time to break the strong bond, right? If you have a strong bond between the particles, it's going to not break easily, right? So you have to apply more of the force, like it's strong, so it will be like taking time to break the bond and to generate it into vapors. Obviously if there will be less vapors, there will be a less vapor pressure, and that's what we can understand. So nature of liquid we have understood. Now let's just talk about the second thing, that is boiling point. Now what do you think, how boiling point is related with the vapor pressure? Tell me guys, everyone, is it directly proportional or inversely proportional? How boiling point is related? Tell me guys, BP, not blood pressure, it's boiling point, correct? So boiling point, how it is related with the vapor pressure. So remember that guys, your boiling point is inversely proportional. Your boiling point is inversely proportional to vapor pressure. Okay, it is inversely proportional to vapor pressure. Why? How you can relate that? Let's just understand with one example. Say you have a liquid, like two liquids are there. Okay, liquid A and liquid B. Now, if I talk about liquid A and liquid B, what you can relate is that, yeah, liquid A and liquid B. Say liquid A boiling point is 70 degrees Celsius and liquid B boiling point is 40 degrees Celsius. Now, the liquid A obviously will start boiling later and liquid B will start boiling before. So, till the time even liquid A, and you started heating both of them at the same time, right? Started heating both of them at the same time. Now, your liquid B will start boiling at 40 degrees Celsius. Tell me guys, your liquid B will start boiling at the 40 degrees Celsius only. Till the time this will start boiling, till the time your liquid A will start boiling only, your B will start boiling and it will form lot of vapors, and it will form lot of vapors. Obviously, it will be having high vapor pressure. So, less is the boiling point, more will be the vapor pressure, and that's what we can relate. Correct guys? So, boiling point increases, vapor pressure decreases, and this is what we can talk about. Correct? Understood everyone? Yeah, tell me. Anyone is having any doubts? Tell me guys. Everyone understood this? Yeah? Okay, let's just talk about the third factor, which is temperature. So how it is going to depend upon temperature guys? Very simple. Temperature is directly proportional to vapor pressure. More temperature you are going to provide, more it is going to convert the liquid into vapor, and more will be the vapors. So temperature is directly proportional to vapor pressure. So this we can understand. I hope everyone understood. Now let's just start with a very important topic. We understood what is vapor pressure. Now let's just start with the really important topic, which is Raoult's law of partial vapor pressure. Yes, what is that? Raoult's law of partial vapor pressure. Now what it says guys, to understand about it, first I will write what statement it is. Like what is the statement of Raoult's law? Let me just tell you that. Okay, and then we'll be talking about many of the things. So Raoult's law of partial vapor pressure, what it says that the solution, for a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to what guys? Is directly proportional to its mole fraction. So this is what we can relate. So what is Raoult's law guys? Yes, Raoult's law, what it states that? Yes, it states that for a solution of, tell me everyone, it states that for a solution of volatile liquids, volatile liquid means what? The liquid which can easily evaporate. Like if I say, all of you have used the nail paint remover, yes? Tell me acetone or thinner which we say. So all of you have used it, yeah? So that is highly volatile. If you will keep that thing in bottle, yes, tell me, if you will keep that thing in bottle and you will keep the lid open, so will you be able to see that thinner after some time in that? Will you be able to see it? Tell me, guys. Yeah, everyone. Okay, very good. So what you can relate, it states that for a solution of volatile liquids, you understood, right? You won't be able to see the thinner in the bottle later. So why? Where it went, it actually vaporized. It vaporized easily right at the room temperature itself, so that we can know. So what do you have to know? How we can define it? It states that for a solution of volatile liquids, yes, for a solution of volatile liquids, the partial vapor pressure, the partial vapor pressure of each component, the partial vapor pressure of each component is directly proportional to its mole fraction. Is directly proportional to its mole fraction. Correct, guys? Very good. So how we can interpret it? That suppose I have a solution, right, in which I have two components, A plus B. A is my solvent, B is solute. So according to Raoult's law, what I am going to say, the partial pressure of A will be directly proportional to XA and partial pressure of B will be directly proportional to XB. Can I write like this? Very good. Now what you have to know is very simple. You cannot solve anything until unless proportionality sign will be there. So you have to remove it. How will be removing it? So PA is equal to P naught A XA. You remove the proportionality sign and use a constant. And PB is equal to P naught B XB. Now what are these P naught A and P naught B, guys? So P naught A and P naught B, they are nothing but they are the vapor pressure of pure components. They are the vapor pressure of pure components. So what are these terms? Can we write? So PA and PB are what, guys? P and PB are the partial vapor pressure of components, partial vapor pressure of liquid A and B, liquid A and B. So both I am taking in liquid form, right? So I am talking about a liquid solution. So one I have taken in more quantity, another I have taken in less quantity. So you can relate that. So what I can talk about is that, so partial vapor pressure of liquid A and B is this. Now what is XA and XB? These are the mole fraction of liquid A and B. A and B, and what is your P naught A and P naught B? These are the partial vapor pressure of pure components. Like when you're not adding that in the solution, you have taken them separately. Like suppose you have taken alcohol and chloroform, like anything, say alcohol and HCl, alcohol and water. So you have taken alcohol and water, before mixing it separately, you have find it out what is the vapor pressure of it. Then after mixing, what is the partial vapor pressure, that we can relate. So P naught A, P naught B is equal to partial vapor pressure of pure components. Partial vapor pressure of what, guys? Pure components. Very good. So this we can relate. Now if I talk about for the pressure of solution, can you find out for the solution what it is going to be? Because I said that solution contains what, guys? Solution contains A plus B gives liquid solution, so which I can consider S. So can I calculate the partial vapor pressure of solution? It is going to be what? It is going to be the pressure of A, partial vapor pressure of A plus partial pressure of B. Tell me, everyone. Yes, understood. Solution contains two components, A and B. So if you want to calculate the pressure of solution, how you will get it? Then you will be adding the pressure of the component, so you will get it. Yes, everyone, tell me. So can we relate that? So according to the Raoult's law, what I got, PS is equal to PA is equal to P naught A XA. Yes, and PB is equal to P naught B XP. What we can do is that, guys, we can mention over here, yes, that this we can mention as an equation. So equation 1 and 2. Yes, so using equation 1 and 2 in 3. So this is your equation 3. So what I am doing? Using equation 1 and 2 in equation 3. So what I got? PS is equal to P naught A XA plus P naught B XB. Correct. So what you have to know, guys, always remember the mole fraction of any two components, the sum of that is equal to 1. Correct, guys? So can I use this equation to get some simplified thing over here? Yes. Let's just understand that. So you know that, guys, I'm writing this again. So PS is equal to P naught A XA plus P naught B XB. Correct, guys? Now what you can relate over here is that XA plus XB is equal to 1. So what I can write over here, guys, tell me what I can write is, I can write XB, or I can write XB is equal to 1 minus XA. Can I write? Can I write it, guys? Yes. And instead of XB, can I write 1 minus XA? So you can write XB is equal to 1 minus XA, or you can write XA is equal to 1 minus XB. You can write in any manner. Okay, guys? So that we can relate. Now what you can talk about? Tell me what you can talk about. You can utilize anything in the equation and you can get it. So for example, here I'm doing, so PS, I'm using this one, 1 minus XA. So PS is equal to P naught A XA plus P naught B. Instead of XP, I'll be using 1 minus XA. So can I open up this equation? Yes. So what I'll be getting? I'll be getting P naught A XA plus P naught B minus P naught B XA. Yeah, tell me, guys. Very good. Now what you will get, the PS value will be, is very simple. You will get, can you take XA common in both of them? Tell me, guys. Yes. So if you will take XA common here, so you will get P naught A minus P naught B plus P naught B. So this is the formula which you are getting for the PS. What is that? Tell me, guys. So if you are given with only one mole fraction, what you can do is that, yeah, if you are given with only one mole fraction, what you can do, you can utilize a formula that is nothing but PS is equal to, yeah, PS is equal to XA P naught A minus P naught B plus P naught B. So this is the formula to calculate the partial vapor pressure for the solution. I hope everyone understood it. If you're not using this, you can use even this also, that PS is equal to P naught A XA. You can utilize this also direct. Okay. If you are getting difficulty to remember this, you can use this also, and from that also you can derive. From this only you are deriving it. Clear with it, guys? So this we got the formula for solution. Now what happened is that your Dalton one scientist came. So this is your Raoult's law. But there is a Dalton scientist. What he came and he said that if your mole fraction of solute and solvent, what you have to know, guys, if mole fraction of solute and solvent, if mole fraction of solute and solvent is given in vapor phase, they are mentioning specifically that if the mole fraction of solute and solvent is given in the vapor phase. So how you'll be doing it, guys? Tell me. Yes. So what you'll be doing over here, in this case, he said that then the vapor pressure of each component can be calculated by his law, that is Dalton law. So then the vapor pressure of each component, yes, then the vapor pressure of each component, tell me everyone, then the vapor pressure of each component can be calculated by Dalton's law. Okay, what Dalton law says that the partial pressure of each component is equal to gamma A into PS and PB is equal to gamma B is equal to PS. Now what are these things? What is this gamma, from where it has come? So gamma A is nothing but, guys, gamma A is equal to the gamma A and gamma B. They are the mole fraction of component A and B in vapor phase. Mole fraction of component A and B in vapor phase. A and B in vapor phase. And what is PS, guys? Yes, P is the total vapor pressure of solution. Total, hi Veena, how are you? Total vapor pressure of solution, and that is what you can relate. Simple, guys. So mole fraction of component A and B in vapor phase, and that's what we can talk about. We can calculate with the Dalton's law, and we can understand that, right? Very simple. So how you calculate it? Like suppose if you calculate mole fraction XA, how you used to calculate? Number of moles divided by number of moles of solution, number of moles of that component divided by number of moles of solution you used to calculate. Yes, if I calculate XB, it will be number of moles of that component divided by number of moles of solution. But how you calculate gamma A and gamma B, guys? Gamma A you calculate with the help of pressure of component A divided by pressure of solution. And how you calculate gamma B? Pressure of component B divided by pressure of solution. Simple, guys. It's so simple. Yeah, it's very easy to calculate the mole fraction in the vapor phase also. Like you can relate that. Yes. So what you can understand, it's really easy. And if it is given, if mole fraction is given to you in the vapor phase, you have to use the Dalton's law. If mole fraction is normally given, right, the concentration, you will be using what, guys? You'll be using your Raoult's law. Very good. Now, on the basis of Raoult's law, now we are going to understand a very important thing in a very easy manner, guys. Yes. So what you have to know, on the basis of Raoult's law, everyone, there are two types of solution which can be defined. On the basis of Raoult's law, what it says that, yes, we know. Now on the basis of that, we can have two types of solution. Now what are those solutions and how we can relate it? So the two types of solution which we can have is, it can be an ideal solution or it can be a non-ideal solution. So on the basis of Raoult's law, there are two types of solution. One is ideal solutions. Another is non-ideal solution. One is ideal solution, another is non-ideal solutions. Now talking about what are ideal and non-ideal solution, very simple, guys. Okay, tell me, guys, for a parent, right, or for a student, for a teacher, who is the ideal student or an ideal kid? Yes, tell me. The one who follows everything what the person says. Yes or no? We'll say, oh, this is the ideal student, all of you should be like this. Or like if I say in the siblings also, one of the sibling is favorite because that sibling actually listens to everything. Correct. So what is ideal solution? What is going to be ideal solution? The one obviously who listens to Raoult's law or the one who follows Raoult's law. Correct. So what are ideal solution, guys? The solutions which obeys the Raoult's law over the entire range of concentration, you call it as ideal solutions. What are those, guys? The solutions which follow the solutions which obeys the Raoult's law, the solution which through Raoult's law I am writing in short form as RL. Okay, the solution which obeys the Raoult's law over the entire range of concentration. Over the entire range of concentration. That you call it as ideal solution. And what is non-ideal, guys? Tell me, what is non-ideal solution? Very simple, no? Right, like if I talk about in a family, right, if you are like 4 siblings, so the one who doesn't listens completely, you say that though this is non-ideal student, or if this is a non-ideal kid. Or what you can relate is that even in the school also, right, for the teachers, who is a non-ideal student? The one who doesn't listen. Yes, correct. Same we can relate, right? So non-ideal solution is a solution which do not obey the Raoult's law. So it's going to be the same definition. Yes, but instead of which, here it will be do not obeys. The one which do not obey Raoult's law over the entire range of concentration, You call it as what? You call it as non-ideal solution. So it's going to be very simple. But instead of which obey, it is written do not obeys the Raoult's law. Clear with it, guys? So the one which obeys the Raoult's law, for that you should know. Yes, the first difference we have understood. So according to Raoult's law, what you have to know, that if you are mixing, you are making a solution, right? So according to Raoult's law, the delta H mix for the mixture, the change in enthalpy is going to be 0. Means neither heat is released or absorbed. Correct? But obviously it's a non-ideal solution, so what it is going to do? It is going to say no, I'm not equal. Correct? So delta H mix is not equal to 0, and that is also a normal thing. No, whenever you do add some things, so either a heat is increased or decreased, right? So what you have to know is very simple. Again, what we can relate, that delta H mix is not equal to 0 for non-ideal solution. Okay, talking about the next differences, what we can discuss is here. Even for ideal solution, what we can relate, when you're mixing two things, it says that delta V mix also is equal to 0. When you're adding two things, so the change in volume is equal to 0, it's saying, right? So what it says, no change in volume after mixing. No change in volume after mixing. Okay, but if I talk about over here, what you can relate, delta V mix is not equal to 0. Obviously, there is a change in volume when you, yes, add two things. So that's what it says in the non-ideal solution. Now, fourth point, what you have to know, that it says solute, whatever solute you have, it neither associates or dissociates. So what you have to know, solute neither. So when you will be adding solute in a solvent, so it says solute neither dissociate or associate. And why do so? What is the reason for it, that why solute neither associate or dissociate? What you can relate is that very simple. It means the intermolecular forces, yes, the intermolecular forces between, the intermolecular forces between, yes, AB molecules, like suppose you're adding A and B, AB molecules is equal to that of, AB molecules is equal to that of, tell me guys, that of AA or BB molecule. So what it says, let me just make you understand that, say you have a liquid A, right? You have a liquid A and liquid B. So when you will be having a liquid A and B, so in that you will be having many of the liquid A atoms, yes, there will be there, no, there will be interactions between them. Like suppose if I say I have a water in a bottle, water bottle, so it doesn't have only one water molecule, it has many water molecules. Like that, there will be BB, there are interactions. Now, but what it says, that when you are mixing both of them, A plus B, right? So it's saying when AB is going to interact, so whatever was the force of attraction between AA, that is equal to BB, and that is also equal to AB. So all of them, they are equal according to Raoult's law. Okay, but generally it doesn't happen. So ideal things, if we say, because they are comparators, so it doesn't exist in general. So what you can know is that for non-ideal solution, you should write solute either dissociates or associates in a solution. So solute neither dissociates or associates in solution. That's what your Raoult's law says. So what you will write for here, that solute either dissociates or associates in a solution. Solute either dissociates or associates in a solution. It means what, guys? Yes, the force of attraction between AB is either less than AA or BB, or AB interaction is more than AA or BB. Can we relate? It means not equal. Correct. The interaction between AA molecule or BB molecule is not equal to the AB molecules, and this is what we can relate. Now, what are the examples of ideal and non-ideal solutions? Yes, the examples for that, I'm telling one, and there is a homework for all of you guys. Yes, you have to tell the example one. You have to tell five example for ideal and non-ideal solution. And next class when I'll be meeting, I'll be telling you. So the example for ideal solution is, yes, N-heptane plus N-hexane. So when you add N-heptane and N-hexane, what happens, guys? What you see, yes, you see that N-heptane and N-hexane, when you see, what you see is that, yeah, tell me, N-heptane and N-hexane. You see the solution which you get is an ideal solution. Okay. And if I talk about the next one, for the non-ideal, you have many, like you have alcohol plus water, HCl plus water. The examples that you see in your day-to-day, like in general, alcohol plus water, HCl plus water, these are non-ideal solutions. Clear with it, guys? Very good. So this we have understood. Now what we have to do, that your non-ideal solutions also can be divided into two. Because here in non-ideal solution, it is not equal. Like V mix is not equal to 0. So if it is not equal to 0, so it can be either more than 0 or less than 0. Can we relate that? So non-ideal solutions, you have to know that it can be defined again into two. So the non-ideal solution showing positive deviation. So non-ideal solution showing positive deviation, and next is non-ideal solution showing negative deviation. Can you relate with that, guys? Very simple. So non-ideal solution showing positive deviation and non-ideal solution showing negative deviation. Now, if I talk about what are the differences between it, let's just quickly discuss about it, guys. It's going to be very simple. Yes, but before that, let's just discuss what is the graph for Raoult's law. So we'll discuss graph for Raoult's law today, and non-ideal solution, what are the types, the positive deviation, negative deviation, that we'll be doing later on in the next class. Okay, so what is the Raoult's law graph, guys? Yes, let's just discuss about it. So Raoult's law, what it says, you remember? Tell me. Yeah, we have studied that, no? That the partial pressure of each component is directly proportional to its mole fraction. So what you can relate is that, guys, that if you are plotting the curve for components A and B, what you can relate is that, say, when you're just plotting a curve for a component A, so mole fraction for that is going to be 1, and for B it is going to be 0. And for B, when you are doing, so B is going to be 1 and A is going to be 0. So what happens if you'll be plotting it with the vapor pressure, right? So vapor pressure, you know that when, yes, when the, yeah, when the mole fraction is directly proportional, so when the mole fraction increases, the vapor pressure also increases for component A. This I can write for PA. For another component, what I can relate is that, so even for that also it is going to increase, that we can write PB. Correct. So when I'll be adding both of them, for that is going to be there for the solution. So PS. So this is the curve for Raoult's law. When you have only one component, so the mole fraction is going to be 1 for that, and for the other component it's going to be 0. For the another one, if I relate, so XB is equal to 1. For X it is going to be 0. What is happening? It's writing by itself. Okay. So someone has come and spammed it as well. What? Okay. So what you can relate is that PS is equal to PA plus PB. Okay. So this is the curve for the Raoult's law. Okay, guys. Now when we'll be discussing about that in the next session, that non-ideal solutions are of two types, which is showing positive deviation and negative deviation. we'll discuss about even more things, or we can just quickly talk about it also little. That non-ideal solution, guys, we have discussed that it can be a solution showing positive deviation and negative deviation. Yes, can I relate with it? So the showing non-ideal solution showing positive deviation and negative deviation, and showing negative deviation. So what it is going to be, it's very easy, guys. Let me make the differences, and that's why I'm doing. So if positive deviation means, we know that for non-ideal solution, delta V mix is not equal to 0. Delta H mix is not equal to 0. So for positive deviation, what you can relate, when delta H mix is equal to positive, means it is greater than 0, then it is a positive deviation. When delta H mix is equal to negative, it's going to be a negative deviation. When delta V mix is equal to positive, you will say a positive deviation. When delta V mix is equal to negative, you will say it's a negative deviation from Raoult's law. When it is going to happen? Yes, let's just understand that. So obviously you have to know when you will get a positive, more vapor pressure than the Raoult's law. When you will get it? When the AB interaction is less than AA or BB interaction. So this is going to be less here, because when it will be less, then only you will get a more vapor pressure, no, than expected. And here you will get AB interaction if it is more than AA or BB interaction. This you can relate. I hope everyone is clear with it, guys. Yeah. Okay, so next class when we'll be meeting, we'll be talking about little bit regarding azeotrophs, and we'll be also doing the graphs for non-ideal solution, how you can relate that. You want me to quickly do it? What say? Okay, let's just do that. It's going to be really easy. Okay, you will understand. So we know what is Raoult's law graph. Yes. Can we make it? Everyone, tell me, can we make the Raoult's law graph? It was XA is equal to 1, XP is equal to 0. XA is equal to 0 and XP is equal to 1. Like that. So we have drawn the curve for it, right? So we can draw according to Raoult's law. It was this. PA, PB. Yes, PA, PB, and that is PS is equal to PA plus PP. Now when I say that it is a positive deviation, so it means you are going to get a vapor pressure more than what was expected by the Raoult's law. So what you can relate? You will be getting the values more than what was expected by Raoult's law. So the value over here, what you can relate, this represents the Raoult's law, and the green one, the dark green one, it represents the positive deviation. Means you are getting the vapor pressure, what expected by Raoult's was the orange one, but what you are getting actually is more than the expected by Raoult's law. Same can I draw for it? Tell me, guys. Yes, what was expected by Raoult's law was this. We can write the same thing. XA is equal to 1, XP is equal to 0. XB is equal to 1, XA is equal to 0. Now you can write this is PA, PB. Correct. This is there. Now what you can relate? Very simple. PA, PB, I can make it like this. No? So it's going to be the same graph. PA, PB. And PS also you can relate. It is going to be this. PA plus PB. This is expected by the Raoult's law, but what actually you get is less than what was expected by the Raoult's law. Yeah. So this is, again, you can understand. Yes. Hello Balveer, how are you? So I have joined very late, Balveer. We are just done with the topic. Just now what we have done, we have talked about the Raoult's law and how you can define the ideal solutions and non-ideal solutions on the basis of, yes, Raoult's law that we have done. So make sure you are going through the whole video and understanding this topic, because we have learned the topic in the easiest manner. Yes, everything will get clear if you will see this video. Okay, Balveer? So make sure you are seeing the video, you are seeing the whole recording. Yes. Now let me just tell you about what we have done today. So we discussed about like quickly I'll be okay. Very good, Balveer. Great. So what we have done, I'll be just quickly summarizing for you that what and all things we have done today, okay, so that it will be easy for you to go through it. So what we discussed, we quickly discussed the Henry's law. In the last class, what we discussed about Henry's law. So I quickly just revised it and also said what are the applications of Henry's law in today's class. So in the carbonated drinks, scuba divers, they use the oxygen cylinders, right? So in that, oxygen is, yes, added with the high pressure, right? It is added with the high pressure. So that is the application of Henry's law. Mountaineers carries oxygen cylinder, same concept is there in that. Then we discussed about what is vapor pressure, pressure exerted by the vapors of liquid, simple definition, what and all things it depends, that we discussed. Then we discussed about Raoult's law of vapor pressure, what it says that the partial pressure of each component is directly proportional to its mole fraction, right? Then we removed the proportionality sign, and what we got a constant which is P naught A, P naught B, right? What is that? Partial vapor pressure of pure components, correct? So that we used and we got the final equation. Then we understood, just like that, with the very simple example, that yes, how we can simplify the formula, that we understood. And we also understood that one scientist came whose name is Delt, and he said that if any time the mole fraction of solute and solvent is given to you in the vapor phase, so how you will be calculating the vapor pressure, partial vapor pressure. So the formula becomes little different, that is PA is equal to gamma A dot PS and PB is equal to gamma B PS. Correct? Very good. Now what is this gamma A and gamma B? Gamma A is the mole fraction of component, gamma A and gamma B are the mole fraction of component A and B in vapor phase. Correct? How you calculate? Like normal mole fraction, you calculate number of moles divided by number of moles of solution. Yes. And gamma A and gamma B, they are the mole fractions in the vapor phase. How you calculate it? By using the vapor pressure of component A divided by vapor pressure of solution. Very simple. Correct? Very good. Balveer, Veena, everyone, I hope you are able to relate with it. Then we understood, just like the way, like if I talk about for a teacher, the ideal student is that one who follows everything, right? What the teacher says, like for most of the teachers. So same way, for Raoult's law, the ideal solution is that one which follows the Raoult's law, and non-ideal solution is the one which doesn't follow the Raoult's law. Then we understood what comes under it, what are the points, the differences we understood completely. And what we discussed that even non-ideal solution is of two types. And before that, we discussed about the Raoult's law graph, then non-ideal solutions, how we can relate with it, what are the types for it, showing positive deviation, negative deviation, what is the meaning for it, how you can interpret it. So all these things we have studied in today's session. So make sure, yes, everyone is revising this and understanding about it. Now let me tell you a very important thing, that if you want to take our plus classes subscription, guys, where we are going to do whole syllabus, the exhaustive coverage of syllabus we are going to do, so this is the time to enroll for it, guys. Today is the last day, because today you will be getting instant 20% discount if you will be using my code, which is MRIS10. So if you use my code MRIS10, you will be getting instant 20% discount, guys. Yes. And already the Unacademy subscription prices are really affordable, but after this offer it's going to be like something which is bang on, like it's very good. Okay, and let me tell you quickly about the upcoming batches for IC class 12. So there's a batch which is already going on, it started from the 1st June, and in the July also a new batch is going to start from the 4th July, so you can join that. Yes, this is for your class like you can relate 12, and for class 11 the Brahmastra batch is going on. Who and all are taking the classes for it? So I'm taking the chemistry classes, and Lakshya Gera sir takes biology, physics classes are taken by Mohana ma'am, and maths classes are taken by Jyoti Lakshmi ma'am. So we all will be covering the whole syllabus, guys. Yes, and let me just introduce you the community which we have in our Unacademy app. So you never miss an update from your favorite educator. You will be getting all the information regarding the classes, you will be getting all the handwritten notes, all the books, material, everything you will be getting over there. And as well as you can share your feedback directly with the educator via polls. So isn't it amazing, guys? Like you can interact, you will be in 24 hours connect with the teacher. Yes, guys. So if anyone is having any doubts, Balveer, Veena, if you guys have any doubt, you can ask to me. Yes, tell me any doubts you have, Balveer, Veena. Yes, Anyone is having any doubts? Okay, very good. So, I hope everyone understood what topic we have done today. Make sure you're revising it once and you start making one formula sheet, guys. Because in the solutions unit, you will be getting many of the formulas. So, just make a one formula sheet in which you are mentioning all the formulas so that it will be very easy for you when you'll be doing the numericals. Okay, guys? So, yeah, okay, guys, we'll be meeting in the next session then. Thank you, all of you. Bye bye. Thank you, guys. Bye, everyone.